Right, hi guys, welcome to one of my YouTube videos that I'm going to have a go at. Right, what to say? First of all, I've got to pretend you're all here. My wife says that's the only way to be. I've got to act, okay? So, put your mobile phone away, right? Concentrate. You, wake up a bit and listen to what I'm saying to you. Right. I'm going to go through this paper, okay, which is the organic analysis stuff. Hopefully it'll make a bit of sense to you, but have a look at the paper first. You should, like I say, you shouldn't be doing this until you've had a look at the paper first and you've thought for yourself a little bit. Alright, organic analysis, all fairly recent, very recent to be honest with you. We'll go through the ideas, go through the thoughts behind it, go through the analysis. Okay, so try and keep it fairly quick, because otherwise it'll be boring. Okay. Question number 1. C5H12O, whatever, could be anything. Alcohol J. He's done the reflux, okay, to form K. What's occurred? Right, well K obviously has C double bond O and no OH. Alright, so K must be a ketone. Therefore, alcohol J must have been a secondary alcohol to form a ketone. Alright? What else does it say? It says it's branched. Right, there's no other information in the question. Time to play. Here we go. 6 marks, dead easy. You shouldn't have a problem with this. Alright? So, spectral analysis. That's what I've just been saying to you. Shows that K must be a ketone. C double bond O, K is a ketone. Because there's no absorbance for OH. So J, there's no absorbance for H on the spectral analysis. So you formed a ketone. J must be a secondary alcohol to have formed the ketone. And if it's got a branch in it, C5, whatever it was, 4, got to stick a branch in, so got to stick it somewhere. And the OH, any place the OH can go to make a secondary alcohol, to make a ketone when it's oxidized, right, is there. So that is the only structure, totally unambiguous, no other possibilities at all. Drawing that out, J, give me the marks, bring it on, there it is. Swivel it on its side to show what K is. C double bond O, I like that poking out. Right, so you've got your methyl there, up here. That H has gone, of course, because it's become water. Part of it, you know, partly has become water. And then you've got CH2, CH3 twice. That's how I represent that. That's how I want to put that. I don't want to just lump it all together because there's branches in there. So I want to make it a bit better than that. Okay. Overall equation, bang, O, there, reflux, job done. No problem. Notice how I show the ketone there, dead easy. Right, next. Right, I think we've met this one before, but I don't see any issues with going over it again. Compound G, branch chain organic compound, does not have EZ isomers, not in bold. Does that mean to say it doesn't have a carbon-carbon double bond? No, it just says there's no EZ isomers. That will mean that the double bond will be on a carbon with 2 groups the same. That's telling me where my double bond needs to be when I get that far in the question. I must have a carbon, probably C double bond C H. H. That won't give me EZ isomers, so I need to perhaps put my double bond at the end of the molecule to sort that out. Okay? Get rid. Right, doesn't have EZ isomers, elemental analysis, yeah, I can do that. Mass spectrum, infrared spectrum of compound G is shown below. Don't like fragmentation patterns, they can be a bit tricky, but we'll go through it anyway. They can be a bit hard. Right, down a bit. What's all this mean? Right, let's have a quick overview. I'll deal with X and Y shortly. Okay, don't want to worry about those. Straight to here, molecular ion peak. 85, 86, smack on. right? That's going to help me. That's going to give me the molar mass. So I go down here. Let's see what the spectral analysis tells me. G, branch chain, okay. G appears to have, without a doubt, a C double bond O and an OH. So, probably, guessing here, carboxylic acid. Okay. Let me just reacquaint myself with what the question says. Not much. Possible double bond. Okay, let's have a look at this. 86 it comes to. Straight in the question, let's get a few marks sorted, shall we? CHO. Okay, right. C, da-di-da, work it out, empirical formula, work out the simplest ratio, that should be fine. Divide by the smallest, C2, H3, O, C2, H3. A lot of, quite a high ratio, carbons to hydrogens, really. It's hard to be specific, C2H3, but it looks like there could be a double bond there, giving me a high ratio of carbons to hydrogens, a higher. Alright, so C2H3O, molecular iron peak is at 86, we've just seen that. So it must be doubled up, which is a relief, because I said there was a carboxylic acid going on there, right, off the infrared. And fortunately, I'm able to double up and give myself what that looks, there's 2 oxygens there, so that seems to have the ingredients for a carboxylic acid. Okay, right. Infrared, you've got to be specific when you answer these questions. You've got to say exactly where the wave numbers are for them, right? Must be a carboxylic acid, must have a double bond in it, okay? And I've left a stick missing there. So, put that in, must match C4H6O2. So 4 in a line, put a double bond at the end, rather than here. If the double bond was here, would you have EZ isomers? Yes, I believe you would, because you've got HH. Would you? Hold up, if there was a double bond there, there wouldn't be an H on there. You could get EZ isomers if there was a double bond there. You certainly can't there. So that's why the double bond is positioned there. So you've got two groups the same, 2 hydrogens on the end carbon, no EZ isomers. There's your structure, job done, 6 marks in the bag. Right. Like I say, I was told to keep these videos short. But, let's see. Right. Compound B can be oxidised, so we'll crack on, right? But I'd like to get the whole paper done if I may. Right, compound B, CXHYO, as always, one of these things with O in there, right? Can be oxidised to form a ketone, so it's a secondary alcohol, whatever, right? What else is it? What are the clues? What are the information? That many moles of B has a mass of that, right? So, I need the molar mass, right? So, moles is equal to the mass of the molar mass. The molar mass of this stuff is equal to the mass, 2.59, divided by 0.035, okay, equals 74. Job done. Right. Molar mass of B going down there, molar mass of B, da-di-do-di-da, is 74. Right, compound B, so 74, what am I doing here now? B reacts with D in the presence of an acid catalyst to form 2 compounds, E and F. Okay, right. You can dive in. 74, got to be a secondary alcohol. That's the only possible structure it could be. And as soon as you see this, B being an alcohol reacting with what looks like a carboxylic acid, because it's got 2 oxygens there, acid catalyst giveaway, one word. What is that word? Incorrect. Esterification. Okay? Because you're reacting alcohol with a carboxylic acid, right, there it is. Okay, down there, so that's my structure. D, draw the carboxylic acid out, no problem. Down we go, and then latch my alcohol on. There, that's the alcohol that I've said earlier, B I think it was. Latch it on, plus water, job done. Okay? What's this baby? Right? Organic compound C is the final percentage composition by mass. Okay, straight away, easy marks on that. Don't make any cock-ups on that. You've got to get these right, because if there's one thing you should be able to do, it's those. So be very careful with how you do these. Infrared spectrum, mass spectrum of compound C is shown below. Fat old peak there, OH for sure. C double bond O there, sharp peak there. Screaming at me, carboxylic acid. Right? What's the question? Oh, God, nasty old fragmentation. Right, okay. Right, this one looks a bit dodgy. So, CHO. Okay, work it out, work it out, work it out, comes to 44. You can probably just see down here, so if you keep scrolling all the time, but there's a molecular ion peak at 88. Overall formula is that, looks to me like a carboxylic acid. Okay, so that's fine. Now, what's the structure of it? Let's see. Well, we have to plan, but this bit, you got to watch. Yeah. Now, fragmentation patterns can be tricky. Okay, but if you look at this, C3H7 plus, don't forget you've got to put a positive in there because these are ions. 43, that's a classic fragment for a propyl group, but we haven't spent a lot of time on this, so watch out. There is a straightforward propyl group, but it could be that. 1, 2, 3. It could be that. That could be in a line. 1, 2, 3 with a plus on it, right? With the H's round it, like that, for sure. That type of ion there. But it could be a branched as well, because if you look, that also. So it's got the same. It's still C3. H7, but this, call it a carbocation, right? Because it's a positive fragment, it's had an electron loss, that's fine. Call it that, there you go, right? It could be that fragment as well. Okay, now, hang on, a secondary carbocation is responsible. It's that. So, I've got this one a bit wrong by the looks. I haven't taken into account all the information. We creep down. In other words, oh dear me, we don't like that. Sure, carboxylic acid, happy, we've established that, but then I need to create, it should be this, because that's a secondary carbocation when it breaks off. Yeah, as we've seen earlier. That is the actual structure. Nice happy face there, how lovely. Okay, guys? I can see you're all going to sleep here. You pay attention, right? Pop your mobile phone away. All right, never mind playing on your mobile phone. Listen to Tim. That's the way it is. Right, next. which is an odd thing, but we'll give it a whirl. What time is it? Keep your neck. Soon goes, though, soon goes. Right, try and finish this quickly. Alright, there's some compound here. Structure of F is shown below. What's the question? Compound F. Double alcohol here. Don't like the look of this, right? What's going on here? What's the empirical formula of compound F? Okay, it's two-stage synthesis. F from B. Right. This putting two alcohol groups on is not the same as hydrating across the double bond. Let me explain. Sure, steam, H2O gaseous, with phosphoric acid catalyst, opens up the double bond, H on one side, OH on the other. Never mind about which side at the moment, we'll deal with that shortly. CH3, CH3, H, H. There it is, look here. That's not the same because there's two OH's on it. Now, hydrating always puts water across the double bond. This is different. You've got an OH on one side and OH on the other. That says to me haloalkanes to make an alcohol, which we haven't done yet, and I have to get onto haloalkanes as the land, we'll see how the land lies, okay? Right. So, I know we've met this before, but it's all good. Sorry. Here. There, Br2. You see, you've got to go via a haloalkane because CBr, like I say, these are haloalkane groups, and you can, with sodium hydroxide, it's called, write this down, nucleophilic substitution. And it's basically this. CX, X being a halogen, nucleophile, I'll come back to this when I teach it. When I do one on haloalkanes, you will see there's a polarity there. Bang, bang. Nucleophilic attack. In other words, any haloalkane group can be reacted with this hydroxide nucleophile produced by sodium hydroxide and latch on. The thing is, they've stuck these on the sides and I've stuck these on the bottom, but that makes no odds. That's the way it is. Haloalkanes, swapping a haloalkane group, if you will, substituting, swapping, call it what you will, for an OH. Not the same route as hydrating an alkene, is it? Right. Next. Now, again, problem is practicals and stuff. I'm at a bit of a loss, but I did do this just as a bit of an extra for you. If you notice, going back, I got preparation notes. Let's have a look. Take an alkene, bromine, turn it into a haloalkane, use reflux to do that. That will give you a mixture of the alkene, unreacted alkene, and the haloalkane intermediate, 2,3-dibromoethane, right, which you've seen earlier. Then, that mixture needs to be separated. I'll come more to this later. When we're talking about haloalkanes and how we separate mixtures and all that, the specific practicals. But always remember, if you have a mixture of liquid organic compounds, they have to be separated. Haloalkanes will have a lower boiling point, a higher boiling point, right? So, alkene first will come off. Haloalkane will distill off second, separating that mixture, okay? That's how it goes when you're separating a mixture of organic compounds. Again, there's stuff I've got to do on that, so don't worry too much about it. Right, next, how much more is there? Right, what's this? This is an odd one, but worth having a go at. Again, student provide a mixture of two structural isomers. Each isomer is a percentage composition of by mass CHBr. Relative molecular mass of each isomer is less than 150. Don't know what I'm doing here. Determine the structures of the two structural isomers. Link the evidence with your explanation. Okay, there's nothing else I can do. Work it out, work that out, C3H7Br equals 123, less than 150, so there's no doubling up. So that's its molecular formula. This is an odd question, this. That's its molecular formula, right? Does it have isomers? Although we haven't done haloalkanes, the same thing applies to everything else in terms of isomers. You play around and you show the isomers of the two structural isomers. Well, I think there's only two. That's told me what it is. Dead easy. 5 marks for that. Giveaway. All right, you should be absolutely cool on it. Bang, bang. 1. Right, name these for me, please. Who shall I ask? Sophie, please. No. Wrong group. It's tricky. Right. Who should... Henry, please. You'll do. Name that one for me, Henry. Otis. Name that one for me, Otis. Sorry, what was that? Incorrect. What a shame, right? 1 bromopropane, 2 bromopropane. Better luck next time, lads. Never mind. Next. Hey up. How much more is there? Bear with me while I just have a quick go through here. Alright, I'm doing alright. I'm trying to go quite fast, but blimey, there's quite a lot. Right, okay. Student heats a mixture of 2 structural isomers under reflux with sodium hydroxide. The mixture of the 2. Okay, those 2 isomers are going to make... This is the business with the nucleophilic substitution that I haven't taught yet. That's the way it is. So I've got a haloalkane in the previous question because this is a continuation of it. I've got 2 haloalkanes from memory, 1 bromopropane and 2 bromopropane, right? Sodium hydroxide, the hydroxide nucleophile. This is nucleophilic substitution. OH in there. It's going to knock into those haloalkanes. It's going to knock the bromine out and replace it with OHs. So you're going to get 2 sorts of alcohols formed. 1 secondary, 1 primary from memory. Of course it is. Okay, so knock that out. Here we go. Right. Compound, so form 2 compounds, yeah. Well, one of them was a primary and one of them was a secondary from the previous question. Look at that now, job done. Obviously, OH, fat OH there, C double bond O, OH there, 3,500, show the stuff. So, compound E, dichromate, that'll be your primary one to form G. Okay, to the one will form, because it's a secondary alcohol, will form a ketone, won't it? So you wouldn't have the OH. Refer like I say. So, G must be a carboxylic acid. What's the question? G, carboxylic acid. Yeah. E, therefore... must have come from one of those 2 isomers that you've, those 2 bromo things that you've changed the Br, as I keep saying, to an OH. So that one will form that. F, the other one, would have, it's got to be that to form the carboxylic acid that we've just determined. That one, F, the other structural isomer from the reacting with the hydroxide nucleophile, the secondary alcohol that's formed, taking the Br off, swapping it out to form that. It ain't that, that's the other one, because that wouldn't give you, that would only give you the C double bond O if that was oxidised. No OH, because it's a secondary alcohol. Okay, well done, guys. G, dead easy. G again, right, giveaway, heated with F. right? So F's the other alcohol. The secondary one that we've done nothing with, small amount concentrated sulfuric acid, says one straight thing to me straight away. Who shall I ask on this? Let me see. Can't remember who's in the groups. Weird. Isabel, please. Isabel, what do you reckon? What do you all think? Esterification shouts at you, of course it does. Job done. You've made an ester, draw it out. No problem. Next. Oh, an easier one. Because this is quite a big old pack, this. There's quite a lot in it, and I know it's a bit lengthy. Right. This is alright. Alcohol A heats under reflux, sulfuric acid, potassium dichromate, organic compound form produces the infrared spectrum below. There it is, look. Lovely infrared spectrum, no broad peak at OH. Sharp peak 1750. Right, alcohol A must be a secondary alcohol to have given me that. To give me that, just that, and no OH. Right, must have formed a ketone. So, which could it be? Down here, let's have a bit of a look, giving it away. Great. Right, what do you say? What do you say? What do you say? I must stand in the centre. Mustn't move around so much. So, what do you say? Tertiary. What sort of alcohol is that? This one. What sort of alcohol? Secondary. Job done. What sort of alcohol is that? Primary. Secondary, primary. Okay. That's a primary, D and all. Okay. Which alcohol is not likely to have a fragment at MZ47 in its mass spectrum? Again, I don't want to dwell on this too much because I'll be here all day. But 43 equals that propyl thing. But it could be, we looked at the previous, a secondary one, right? Not likely. That will. That's my secondary there. That's going to produce my secondary, that baby there, right? That one, no. Can't see any obvious fragments that match that. A. Look at it, take care on it, and have a think about it. Right, I'm not going to bother with all this, really. Describe the reactions of butane 1-ol, formaldehyde and carboxylic acid. Explain using a diagram how the aldehyde can be produced in the laboratory. We're talking distillation. Okay. We know all this. There's my butane 1-ol. Straightforward reaction. Butanal. There it is. That one there. Mistake. Where's the mistake? Where's the mistake? Right, any ideas? Precisely, I knew you'd get it. There should be a 2 there. I don't know why I've missed that out. Should be a 2 there. That's rubbish. Okay? Anyway, there you go. How do you separate that before it becomes that? And C, use distillation. Okay? Because distillation can make and separate simultaneously if something's got a lower boiling point. Remember that. Okay? So, down we go. Quick fit, distillation, blah, blah, blah. Top diagram, even though I say so myself. Finger beauty. Okay? Sorted. Alright? Seven. I want to go a bit faster. 7. Oh, we ain't far off now. Right. 7. Trans stereoisomer. Right. We're talking carbon-carbon double bond. Useful intermediate in organic synthesis are my word. Elemental spectral, F. Yeah, could do stuff with that. Infrared spectrum of F. Well, seems to be a sharp peak C double bond O here. No OH. That suggests to me F is a secondary alcohol, right? Because it hasn't formed a big broad thing here. And it's got to have like cis and trans isomers. Secondary alcohol, cis and trans isomers, keep it in your brain. Mass spec, 70 molecular ion peak. Remember that. Fragments 41, I don't know. Right, down here, so 70, big old fragment. Right, let's do it. Right, work out the empirical. There it is. Okay, C4H6O. Quite a high proportion of C's to H's, which suggests that there is a double bond, hence it can have transisomers. It's all looking good so far. Spectrum, no OH, we just discussed it. Mass spec, molecular ion peak at 70. So that reaches that matches that. Molecular formula is the same as the empirical formula. Okay, because it could be an aldehyde, right? You fool. Right, I think it's going to have to be an aldehyde. I nearly forgot that. That's poor, that is. Right? Either way, you play, right? And do not play until you play yourselves. I've said this to you. You should. This is how you get confidence in these, by working them out yourselves and being able to do them. Not waiting for Tim to just come along and tell you the answer. Waste of time. So give yourself some, what's the word I'm looking for? Confidence. Right, and have a go. There you go. I've got an aldehyde group in there, which matches it. It matches the empirical. I'll put a double bond in there. H is on either side. That'll give me cis trans isomers. And I've drawn them out. Job's a good one. Next. Right. 31. I don't fancy this much. Chalcoal's likely to have a fragment of 31 in its mass spec. 31. Dunno. Have a play with those. The answer's D. Alright. Thank you very much for your time. See whether you can get 31 on that. Wait for the next one, guys. See you later.